In Safran and Orolia, we are focusing in resilient position, navigation, and timing technology. And at the Autonomous Challenge at CES, position, navigation, and timing is key to make sure that the cars can function with these high speeds with good accuracy and to maintain their capabilities as well too. The breadth of portfolio and the capabilities that Safran and Orolia have in navigation and timing can help support the students and the universities to use our technology and leverage that to make improvements by driving these faster cars on the speedway today.
So we saw the history that the DARPA Grand Challenge had played in really launching the autonomous vehicle industry, how it got industry and academia and government to all work together on what was at that time a grand challenge of could you get autonomous vehicles to operate even at low speeds. We saw a gap that there was not as much work being done around high-speed automation. What better way to do that than motorsport?
Having an autonomous Indy challenge that overlaps with CES, I think is a great opportunity for so many people that come for the automotive technologies, and for my students to see some of those companies at CES, and then for the companies to come here and see the students and interact with the students, I think is a great opportunity.
Oh, the students are fantastic. This event is fantastic because they are really pushing the boundaries of taking high speed and leveraging position, navigation, and timing technology and really testing its boundaries.
I am a robotics person at heart, and so coming to this arena was definitely a bit of a transition. Race cars are definitely faster and less maneuverable than the robots that I'm more used to working with. But I think part of what got me really excited about this arena is really seeing the enthusiasm that other people have for it. Everybody looks at this race car and they immediately say, this is amazing. And they look at us operating this robot car and they say, you guys are doing really amazing work.
It's a lot of time that we're spending out here. It's a major commitment. We have like 5 track days and 3 garage days all tightly packed in a row, and it's it's like some good sleepless nights out here, really making stuff go, making sure that you're ready for the next track day because you don't know when you have an opportunity to run. Really, really cool to see it all working out when it does work out.
We're very thankful to Safran being one of our sponsors. We got to know Safran through Orolia, so we have one of their simulators in the lab, and really thought it was a great mix to be able to use their simulator for a lot of our development and testing. We're very excited and thankful to have Safran as one of the main team sponsors.
But the product that we're showcasing here right now is a program called Skydel. It is a simulation system for GPS or GNSS technology. And it's an innovative approach on creating a testing environment. And when I say testing environment, I'm talking about really positioning, navigation, and timing. The Skydel simulation engine is truly the core where we can create almost any type of environment. Not just GNSS, we could actually have sensors or other devices in the system. And what we do very different is that we actually allow people to add on or build capabilities on top of that engine. So if there's a certain functionality, a specific sensor, an inertial device that you want to actually add to it, we do that. And the reason we love working with universities is because it's some of the newest, freshest, most innovative ideas that come out of there.
I think we've continually improved our capabilities and our reliability and robustness in the code base. We've been learning more and more every year on how to make the car operate robustly and well and safely on track, which is great. It's great to get out on the track and do good and see positive outcomes out of the code and the systems that we've been developing for so long. It's really great to see it get out on the track and have a really good run.
The GNSS, GPS, and position, navigation, and timing, that's now omnipresent. We cannot live without it, both in the commercial space and definitely in aerospace and defense. A critical infrastructure, right from smart grids, data centers, and automotives as well, are highly dependent on that. With Safran and Orolia, we are very focused on aerospace and defense, but also in critical commercial infrastructure, and really investing in pushing the boundaries and making it more accessible to make sure that everyone has resilient position, navigation, and timing technology is key for us. And that's what we're looking forward to for the future.